Let's take a look at a couple examples here involving using z-scores to calculate areas under the curve and percentiles or comparing other sort of data to one another. So our first example here, our class has an average mark of 75% with a standard deviation of 10%. I made those numbers up. If your mark is 87%, what percentile are you in? So what does percentile mean? Well, percentile always tells you what percent of the data is below you or you are above. So what percent, let's try that again, percent of data are you above? So and it's always helpful when you're doing this, at least at the beginning, to just sketch yourself a little normal curve like I've done up there in the corner, indicate where the mean is, and start labeling some of the data on your little sketch there. So if our average mark is 75, okay, and our mark is 87, that's going to be over here, okay, above the mean. If we're interested in the percentile or the percent of data that you are above, we want to know what percent of the data is in this red shaded region. So everything from 0 all the way up to our mark of 87. Okay. So I'll just say that this is the area that we want, that entire red region there. So how are we going to do this? Well, let's calculate our z-score here, or our z-score. Okay, it's going to be our value, 87, minus the mean, 75, take the absolute value, and divide by our standard deviation, which is 10. Punch this into our calculator. We get 1.2 standard deviations. Okay, so remember, it's not 1.2, it's 1.2 standard deviations. And are we above the mean or below the mean? We are above the mean. Once we've got 1.2, we go to our table and we look up the area that is associated with 1.2 standard deviations. So who's got their table handy here? What do we get in terms of an area that is associated with 1.2 standard deviations? What'd you get there, Cal? 3849. Now, what does this number 0.3849 correspond to on our curve? Well, it is the area from the mean up to our z-score. So it's that blue shaded region from the mean up to our z value. So in order to get our percentile, we know that it's 50% of the data up to the mean. We just have to add on the area from the mean up to our value. So the area that we want is half the data, 0.5, plus our 0.3849, which gets us 0.8849. And if we're given our final answer, we're probably going to round that off to the 88th percentile. So in both of the examples we've done so far, we have looked at a single z-score in order to get our final answer. Sometimes, though, you're going to need to calculate two z-scores or two z-scores to get the area that you want. So another class has an average mark of 72% with a standard deviation of 6. What percent of students have a mark in the 70s? Okay. Now, when we say mark in the 70s, we're going to assume that all the marks get rounded off to the nearest whole number percent. So a mark in the 70s is going to be anything from 70 to 79, if there are no fractional marks. So a mark like 79.5 or 79.6 is not going to exist for the purposes of this question. Okay. So what do we need to do here? Well, we want to figure out, let's label the diagram. Our mean mark is 72, standard deviation 6. What percent of students have a mark in the 70s? So a mark, we want to figure out how many are in between 70 and 79. What percent of the data are between those two values? A mark of 70 might be over here, a little bit below our mean, and a mark of 79 might be over here, a little bit above our mean. So this is the area between those two that we are interested in. So we want that red area in there. So how are we going to proceed here? I think we need to calculate the z-score for both 70 and 79 to get the two areas combined. So our z-score for 79, I'm going to say, let's do 70 first. I'll say z70. So just that little subscript of 70, so you know which z-score this corresponds to, is going to be the value minus the mean, so 70 minus 72. We take the absolute value, and we divide by the standard deviation, 6. We punch this into our calculator, 0.33 sigma. Okay, so 0.33 standard deviations, and 70 is below the mean. Let's do the same thing for 79 here. So our z-score for 79, and I'm leaving a little bit of space here because we're going to want to get the area associated with that, with our z-score of 70. Our z-score of 79 is going to be the absolute value of 79 minus 72, again, divided by 6. 79 minus 72, 7 divided by 6 is 1.17 sigma, and 79 is above the mean. So now we would go to our table and get our area associated with our mark of 70 and our area associated with our mark of 79. So looking this up in the table, we get 0.1293 for our z-score of 70 and 0.3790 for our z-score of 79. So what do we need to do with these areas in order to answer our question here? What do these two areas represent? Let's get a couple of colors here. Kale? We're going to add them together, right? Our z-score of 70 tells us the area between the mean and our value of 70, so this green area in here. Our z-score of 79 gives us an area of 0.3790. That represents the area between the mean and our value of 79, so this black area in here. If our total area is between those two red bars, we want to add those two areas together. So our total is going to be 0.1293 plus 0.3790 gives us a value of 0.5083. So we can sum this up by saying about 50.8% of students are in the 70s. Okay. So in our last example, we're going to look at using z-scores to do something a little bit different. Basically comparing numbers which you can't always directly compare. So let's say I am a student at this school. here is a summary of my grades. I'm taking advanced statistics where I have an 85. I'm taking film appreciation where I have a 95. And I'm taking finger painting where I've got a 79. Okay? Which one of these courses am I doing best in? Okay? Now, if I just said, what course am I doing best in, you would say, film appreciation. You're knocking that out of the park. You got a 95 there. What course am I doing worst in? Clearly, finger painting. I really need to up my game there because that's my lowest mark. But I don't want just which class I have the best mark in. I want which one I'm doing best relative to the rest of the class. So I have to compare my mark to the course average. So you might look at that and say, okay, well, advanced statistics, he's 10 above the average. That's pretty good. Film appreciation, he's 12 above the average. That's pretty good. And finger painting, he's 11 above the average. So it looks like film appreciation is still really good. He's 12 above the average. But we also have to take into account how spread out the data are. How likely am I to be that far above the average just by random chance? Okay, it could be that there's a lot of people who are really big, really far above the mean in film appreciation, so it's not all that special for me to be that far above the average. So z-scores give us a handy way of doing that, taking my mark, the course average, and the standard deviation all into account and getting a single number that we can compare. So let's calculate the z-score for each one of these courses. So for advanced statistics, my z-score is going to be my 85 minus the course average, 75, divided by standard deviation, 9, gives me 1.11 sigma above the mean. So I'm 1.11 standard deviations above the mean in statistics. In film appreciation, my z-score is going to be 95 minus 88 divided by 12 gives me 1.0 standard deviations above the mean. Sorry, I wrote 88 there. It should have been an 83. So 1.0 standard deviations above the mean. And there's a V in above. My last course, finger painting, my z-score there is going to be 79 minus 68 divided by 6. In that course, I am 1.8 standard deviations above the mean. So which course am I doing best in? Well, relative to the rest of the class, finger painting is where I'm really shining relative to all these other people. I don't know what kind of a course this is, that all these people haven't mastered finger painting. But I'm doing pretty good here. I'm 1.8 standard deviations above the mean in finger painting. That's the one that I should take home and put on the refrigerator for everybody to see. So let's just sum this up. I am doing best in finger painting.